Hello again. So I ended the last lecture. Hold on. There's something spinning, and I'm not sure if that's like a thing or not. I guess not. Okay. So I ended the last lecture, and I said I would look up that comminuted fracture. It's similar to an impacted fracture. Impacted fracture is where two bones they push into each other. So this often happens in like vertebrae where the bones get pushed into each other and you end up having an impaction of the bones. So they like one is inside the other ish. This can also occur when you have one bone that breaks and then like the distal region pushes up into the proximal region of that bone. But a comminuted fracture occurs when you have a break within the bone and you have lots of, and usually again due to increased pressure. So it is similar to that impacted fracture, but you end up having a lot of little tiny pieces of bone that are going to be so little fragments of bone fragments that are going to be found within that area. And you don't have one bone pushing into the other bone like you do in the impacted fracture. I hope that makes sense to everybody. And if not, we can always talk about it in class because you can always bring it up and ask, you know. All right, so if you have a broken bone, bones do have a mechanism of healing. It is highly vascular, so bone does heal, and it typically heals relatively well if it's been set properly. So there are 4 basic steps to bone healing or fracture repair. The first is going to be a fracture hematoma will form. So at the site of the bone break, you also have blood vessels that have broken, and you're going to have blood pooling to that area, which is going to cause swelling. You have nerves there that are going to send signals, so you're going to have pain, you're going to have swelling. The swelling is actually beneficial because it'll keep you from using your bone in that area and let you know, hey, there's something going on. Maybe you need to get this checked out. The swelling also functions in causing immobilization of that site and allows white blood cells to come in and clean up the environment. So that's what that hematoma does. Then you have a soft cartilage callus composed of fibrocartilage. The fibrocartilage forms around the bone, kind of basically protects the bone, gives it a structure so that it can heal itself. And then as blood vessels mend, bone cells can move in, bone building cells can move in and take over or can basically override that cartilage, and they start forming a bony material, and a bony callus has formed. The last step is bone remodeling. This can take anywhere from 6 to 8 weeks, and sometimes even longer, depending on the severity of the break and the health of the individual. Hold on one second, okay? Nope, that's not what I wanted to do. I just want to end this for a second. I want to make sure that it is, okay, just making sure that I know it sounds weird, but I wanted to make sure that I was actually videotaping everything I'm saying so that I don't lose this time that I'm lecturing, because that would be sad if that happened. All right, so now we're going to talk about what stimulates bone formation. And so there's a lot of factors that will influence your bone formation. Bone formation is going to be mainly stimulated by hormones telling your body to build up bone when you need it or break bone down if you don't need it. But also exercise and nutrition are going to play a role in bone formation. So you've all heard that saying, use it or lose it. This applies to muscles. This applies also to bones. If you're not using your bones, then you're not going to produce more bone tissue. There's no point in using energy to make bone up. And in this case, if you're not using your bones, bone breaking cells, osteoclasts, are going to resorb bone and release the calcium so the calcium can be used for other functions. So nutrition-wise, there's a lot of different nutrients that play a role in bone formation, but the two major nutrients are calcium and vitamin D. So calcium is a nutrient that we take in. We don't produce our own calcium. And vitamin D, though, we can produce. So vitamin D comes from sunlight. Specifically from the UV radiation, our keratinocytes in our skin can take in the UV radiation and produce a pre-vitamin D that can then move to the liver and then the kidneys. And as it's moved, it is converted into new molecules. The last in the kidneys is calcitriol, the active form of vitamin D. And we have hormones. So hormones are what are going to be the major drivers of bone formation or breakdown. And the two main players that I typically talk about are calcitonin and parathyroid hormone. But during childhood development, human growth hormone and thyroid hormone play a huge role in causing bone formation to occur, which causes growth in the body so that we get larger, taller. And so I've talked about sunlight in chapter 5, and you watched that video on the biology of skin color where we talked about eumelanin and pheomelanin and the benefits of both and the driving force from U to pheomelanin. The factors that are going to influence skin color, all that. One of the factors that influences skin color is the ability to absorb UV radiation so we can produce vitamin D. The lighter the skin color, the easier time we have in absorbing vitamin D. And so this is going to be important in environments where UV radiation is not as intense. So in those hotter, sunnier areas closer to the poles, we have more UV radiation, and so it's a lot easier to absorb UV rays and produce vitamin D. In areas farther away from the poles, we can't produce that vitamin D near as easily, and that's what drove the change evolutionarily from UV or from eumelanin to pheomelanin. Calcium is another major driving force. So the active form of vitamin D is calcitriol. Calcitriol functions in allowing us or helping us to absorb calcium. Calcium is taken into the body through the foods and drinks that we have. And we have to maintain calcium levels. So our blood calcium levels are very closely maintained. We need to have enough calcium in our blood to not only keep our bones healthy, our teeth healthy, but also to allow us to have normal nervous and muscle contractions and signals. So the nervous system functions or sends signals out, but only because calcium is available. Our muscles contract, but only again because calcium is available. And blood clotting occurs only because calcium is available. If calcium is not there, then we would not be able to clot our blood, we would not be able to contract our muscles, and we would not have nervous impulses. And basically we'd die. So it'd be really, really bad. So we need calcium. We need enough calcium, but not too much calcium. And so the two driving factors for calcium homeostasis, the two major driving factors that I talk about, are parathyroid hormone and calcitriol. And so this is just my own homeostatic mechanism. So here we have optimum calcium levels, and this is my little teeter-totter. Over on this side, we have low calcium levels, and over here we have high calcium levels. So if calcium levels start to either go too high or too low, then we're moving out of homeostasis, and negative feedback is going to bring us back to homeostasis. So in this case, our calcium levels become too high. When calcium levels become too high, calcitonin from the thyroid gland is released. Calcitonin then stimulates osteoblasts to produce osteoid, and it stops osteoclast function. So osteoclasts stop breaking bone down, and this increases the amount of calcium our bones will absorb and take back in because we're building up bone. This brings us back to homeostasis. If calcium levels become too low, then parathyroid hormone is going to be released by the parathyroid glands. Parathyroid hormone stimulates our kidneys to release calcitriol, and so these two hormones then work together. Calcitriol stimulates the uptake of calcium from our kidneys and from our intestines, so we don't lose as much calcium through urination or defecation. Now we have more calcium in our blood than parathyroid hormone causes osteoblasts to stop functioning. So it slows osteoblast activity, so we stop building bone up, and it causes osteoclasts to start resorbing bone, breaking bone down, which releases more calcium into our blood. This again brings calcium levels back to optimum. And so we're constantly producing bone. Like I said, we start producing bone in the uterus at around week 8. This is also the end of week 8. We have the full embryo. We've actually went through organogenesis, and now we have a fetus. At the end of week 3, we have an embryo. So at the end of week 8, we have a fully formed fetus, which looks like a human child in general, and it contains bones. So this child has bones in their body already that are forming. So we are building up bone all the way to about 30 years of age, and we can increase bone mass to about 30 years of age. Once we hit age 30, our bone mass has peaked. We no longer can really build up a lot of bone, but we can maintain our bone by continuing to exercise and do activities of a weight-bearing nature. So walking, running, weightlifting, anything that is going to put stress on our bones is going to improve bone density. But once we have hit 30, then bone mass is going to start to decrease, especially if we are not active. So more sedentary lifestyles are going to be more prone to bone loss than active lifestyles. And women are more prone to losing bone faster than men, partly because of the hormone differences. So testosterone helps to increase bone mass in males. Females have very minimal amounts of testosterone, and once we hit menopause, we don't produce much estrogen anymore either. And that's going to cause us to lose bone mass a lot faster. So once we go through menopause, we really lose a lot of bone mass, which is one of the reasons why we need to make sure that we are as active as possible until, so that our bones are healthy. So this leads us to osteoporosis. And most of you, no, I'm going to say 100% of you have heard of osteoporosis because it's not like it's a uncommon disease. Osteoporosis is the loss of bone mass, and this loss of bone mass is associated with aging and can be linked to both males and females. So all individuals can have or are likely to have some form of bone loss as we get older. But females are going to be the most common individuals that are going to suffer from osteoporosis and from bone breaks due to osteoporosis. Treatment for osteoporosis, so is going to depend on if you are under 30 or if you're over 30. But in both cases, whether you're under or over 30, one of the major things you can do is exercise, run, walk, lift weights. Anything that's going to put stress on your bones is going to improve your bone function and bone mass. But if you're under 30, you can also try to increase the amount of calcium in your system. If you're over 30, make sure that you're getting enough calcium so that you're not losing calcium. All right, and this is the figure that shows osteoporotic bone and normal healthy bone. So here you have healthy bone, here you have osteoporotic bone. This bone is definitely easier to break than this bone. So you definitely, the more you put stress on your bones, the more you try to improve bone health, the better your chances are of having healthier bone than this, okay? At this point, we finished chapter 6. Make sure that you go through those end of chapters questions. Make sure you go through the essay questions. Make sure that you can take the information you've learned and then critically use that information to answer other questions. Instead of just, spitting out the information, can you use it and apply what you've learned, okay? So here are a couple questions that I'm going to have you think about on your own. Here's the first one. Here's the second one. So if you're driving, I guess I should tell you. First question is, what is the type of bone growth in which we grow in length? The second one is, what is the type of bone growth in which we grow in width? Next one, here's a application question. Maria is diagnosed with hyperparathyroidism. She has a tumor on the parathyroid gland that causes the gland to produce excessive amounts of parathyroid hormone. So the first question, straightforward question, what does parathyroid hormone do to bone? What type of an effect? The second question, this is where we're applying information, would administration of vitamin D help? So do we want to add vitamin D, maybe give her a drip with vitamin D solution? Or is that not going to benefit her? The next question, these are my brothers, Charlie and Scott. This actually did not happen, but I always like to, use family members or use people I know. So Charlie and Scott are in an accident together and they received identical breaks in their left femur. How did this happen? I have no clue, but they did. And so Charlie, his doctor put him in a bed, said you can't move, while Scott was put into a walking cast. So he was told, I want you up and walking around. Which of the two patients, Charlie or Scott, will heal faster and why? So again, this is an application question. You've learned information, now explain why this is going to happen. Tell me the answer and explain, okay? All right, I'm done with this chapter. I am going to upload this third video, and then I'm going to get to chapter 9. Remember, chapters 7 and 8 are all the bones of the body. I have videos that I will post, or I think I've posted one of them. I will post chapters 8 videos, and we'll go over those bones in lab. So I'm not going to post lectures on them because it's just not just like, oh my God, it's not that important, but it's the bones of the body and it's what we're going to do in the lab, okay? All right, I will talk to you next time. Bye.